Okay, illustration 1. Let me read the question to us. The question says, a customer has asked a firm to produce a bill for the supply of 1,600 units of products. Production will be in batches of 100 units. The firm has estimated that the time for the first batch of 100 units will average 50 hours per unit. The firm also expects that an 80% learning curve will apply to the cumulative labor hours on its contracts. Full stop. A. Prepare an estimate of labor hours of fulfilling these contracts. B. Estimate the incremental hours of extending the production run of producing an additional 1,600 units. C. Estimate the incremental hours of extending the production run from 1,600 to 2,000 units. Now, from this particular question, when you see a question like this, the first thing that you'd want to do is to analyze the question. Now, solution to example 1. Now, we are given in the question, what are the things that we are given? The first thing that was given is required production. Required or expected production is equal to what? 1,600 units. Right? We are also told that it will be produced in batches of 100 units. Therefore, first batch should be 100 units, right? We are also told another thing. We are told that for the production of the first batch, the average hours will be what? 50 hours per unit. So, required time for the first batch is equal to 50 hours per unit. Are we together? Now, this is the information that we have been given. Now, the first question that we have been asked is to prepare an estimate. No, there's one other information we're given. We're told that the learning curve rates we are told that the learning curve rate is what? 80%. Alright? We are given the learning curve rate 80%. We are told that 50 hours will be required to produce 1 unit for the first batch. What's the first batch expected? 100 units. And the total required production from the customer is 1,600 units. Right? So now, this learning curve is explaining the fact that, okay, for the next batch, every next batch that they produce, right, there would be a reduction of 20% of the time required to produce it. That is what it means. Meaning only 80% of the previous time would be required to produce the next batch. When we go to the next batch, only 80% of it will be required to produce the next batch, and as learning keeps taking place, the time taken would be reduced continuously. Now, what do we now need to do? The first thing that we need to do in this question is to calculate the average time, okay, for each batch. Is to calculate the average time for each batch. So, A. Calculation of the average time. So the first one is, okay, they gave us 50 hours as the average time to produce the first batch. It means this is what? 50 times 1 give us 50 hours. They have already given us this for the first batch, right? So for the next batch, what we are going to do is we are going to apply the learning curve percent. So the learning curve percent is 80%, times the first hours given. So if we multiply that, we are going to arrive at what? 40 hours. Right? We are going to arrive at 40 hours. So the next, we are going to say the same 80% times 40 hours. That will give us 32 hours. Right? If we apply it to the next one, times 32 hours, that will give us 25.6. Alright? And we'll apply it again, times 25.6, that will give us 20.48. Okay? And let's do it one more time. If we apply it 80% on, that would give us 16.38. Now, after you must have done this, the next thing to do is to put this in form of a table, right? The next thing to do is to put it in form of a table. Now, I want to use a tabular form because they told us that we should prepare an estimate of labor hours to fulfill the contract, right? Now, the next is, this is the first question that we are answering. To fulfill the contracts. Okay? So the first thing that we'll bring is the batch. Alright? After the batch, we'll bring the average time. And after the average time, we'll have the what? The total time. Okay? So, now, they have already given us a clue about the batches. They told us that the first batch would be what? Would be 100 units. So the first batch here would be what? 100 units. Okay? And when you are using the tabular format, right, you will need to take into consideration what we call the doubling effect. Meaning, for every batch, alright, it will be the previous batch multiplied by 2. So the next batch here will now be 100 times 2, which is 200. 200 times 2, which is 400. 400 times 2, which is what? 800. 800 times 2, which is what? 1600. 1600 times 2, which is what? 3200. Alright? The doubling effect has taken place. Now, the average time is what we have calculated here. Okay? The average time is what we have calculated. So we'll just transfer into the table. So right now, the first batch is going to be taking 50 hours. The next batch will take 40 hours, followed by 32 hours, followed by 25.6 hours, followed by 20.48 hours, followed by 16.38 hours, right? Once we have done this, the next line of action is to multiply the batches with the average time. Okay? So if we multiply, this will give us 5,000. This will give us 8,000. Right? This will give us 12,800. This, look at what I'm multiplying. Right? So 1,600 times 20.48, that will give us 32. What do we have? Okay, we have not done this. This is 20,480. 20,480. This multiplied by this will give us 32,768. And this multiplied by this will give us what? 52,416. Alright? Now that we have done this, this is the tabular format. The question says, prepare an estimate of labor hours of fulfilling this contract. The estimate of labor hours to fulfill this contract. What is a contract? The production of 1,600 units. So you are now going to go straight to the table and say 1600 units, what is the total time that is required? So the answer is the estimated labor hours for producing 1600 units is equal to 32,768 hours. So this is the answer to the first question, right? This is the answer to the first question. Question B, we're asked, estimate the incremental hours of extending the production run of producing an additional 1600 units. An additional 1600 units. Now, this is 1600. On the table, 1600 has a doubling effect. So when we double 1600, we have 3200. So we have the exact total time for the production of what? 3200. So the incremental time between the production of 1600 and 3200 will be this total time for the production of this minus the total time for the production of this, which is equal to 5216 minus 32768, right? This minus this is 3000, this is 16. Remember they said the incremental for doubling it, right? So that will give us what? That will give us yes, we subtract that will give us 19680 hours. 19680 hours. That's that. The next question is, they said we should estimate the incremental hours of extending the production run from 1600 to, right? Incremental hours from 1600. They said from 1600 to 2000. Now, you need to observe this closely. If you check, from 1600 to 2000 does not give us a doubling effect, because the doubling effect of 1600 is 3200. So we don't have 2000 on the table. Let's say we have 2000 units on the table. We would have just subtracted the previous from the former, the previous from the latter. Then we are exactly what we did here. But in this case, the incremental hours from producing 16 to 2000 does not give us a doubling effect. So what are we going to do? In this case, we are now going to apply the algebraic format. And what is the algebraic format? The algebraic format is y is equal to ax raised to power minus b, right? Y is equal to ax raised to power minus b. So I have told us that where a is equal to what? A is the average time per unit spent on the first batch. Okay? X, where X is what? The index of learning. Index of learning. And the index of learning is gotten by what? It's gotten by the expected output divided by the number of units in the first batch. Expected output divided by units in the first batch, right? And B is equal to log of learning curve divided by log 2. So that is what we are going to use to solve for the last this thing now. So I'm going to rub this off. So right now we have been told in the question that A, therefore y is equal to, what is our A? Average time per unit on the first batch. What is the average time per unit on the first batch? We're told that that is what? That is 50. Right? The next is what? Is X. They said X is the index of learning. And how do we get that? Expected outputs. Expected outputs. Right? Or before you do this, I would advise you to first calculate, what is it called? To first calculate your B, because you would need it. Your minus B is equal to log of what? Of learning curve. What is the learning curve percent we were given? We are given 80%. That is 0.8 divided by log 2. Right? Divided by log 2. So when we divide that, we are going to have minus 0.329. Minus 0.3219. So you can check that out. Right? So after we must have done this, we can now go ahead to substitute. Y is equal to A. We have been told that A, or let's put it, A is equal to, in the question, A is the average time per unit on the first batch. We are given the average time per unit on the first batch, which is what? 50. Right? X. We say X is the index of learning. And how do we get the index of learning? Expected outputs. What is the expected output from this question? The expected output is 2000 units. Right? 2000 units. The expected output is 2000. You said the expected output divided by units in the first batch. Units in the first batch. So in this case, what is the unit in the first batch? This is the first batch. 100 units divided by 100. So if we divide this, we are going to have 20. So we are now going to substitute everything we have now in the function. So y is equal to ax raised to power minus b. Y is equal to, what is A? 50 times, what is x? X is 20. Right? What is b? B is minus 0.3219. So y is equal to, if we multiply this, alright, so if we multiply this, we are going to have 19.06 hours. 19.06 hours. So in this 19.06 hours, the total time for producing 2000 units is this 19.06 hours times 2000 units. Right? We are now going to say, therefore, total time for producing 2000 units is equal to 2000 times 19.06 hours, right? Which is 2000 times 19.06 hours. So if you multiply that, what do we get? We have 38,120 hours, right? So if this is the total time for producing 2000 units, right? And the total time for producing 1600 units is this. Okay, the incremental time is what we have been asked. What is the incremental hours that was spent? Therefore, the incremental time for producing from 1600 units to 2000 units is the total time for producing 2000 units, which is 38,120, minus, right, the total time for producing 1600 units, which is 32,768. That will give us what? Right? That will give us what? Right? So the incremental time for producing from 1600 units to 2000 units is the total time for producing 2000 units minus total time for producing 1600 units, which is 38,120 minus 32,768, and that will give us 5,352 hours. So this is the answer to the question. So this is the solution to illustration 1. I implore you not to take this illustration for levity, because they are very, very examinable. But if you know that this has been helpful to you, just give it a like. I want to see your comment on the comment section, and I also want you to like this video and share to your friends. Now, illustration 2.